From Chicago, welcome to 3Degrees Discussions. I'm your host, Mike Vasquez. This is a podcast devoted to the stories behind the innovators, entrepreneurs, and leaders in the 3D printing industry.
My dad said to stay out of it. Said, don't go into the shoe business. So, of course, I made every effort not to. I got a chance to work for a medical company for a short period of time, helping with the engineering department and their intra-aortic balloons, if you're familiar with those. It's a device to assist a heart that's failing to keep the patients alive. But then moved into working in an industrial design company for a short period of time when I realized I needed to find something more interesting.
That was Paul Bates. Paul's an additive manufacturing lead project engineer at ASTM. He's an experienced practitioner of the safe use of additive manufacturing in both the commercial space and the training space. Paul has used almost every form of 3D printing over the last 20 years to develop both prototype and finished goods. He's developed business justifications for the use of these technologies, as well as designed and built the facilities to house them through his work at Reebok, UL, and now ASTM. Before we get started, head over to www.3degreescompany.com and subscribe to the podcast. Remember, you can listen to the show anywhere you download your podcast, including Spotify, Apple, Amazon, or Stitcher. All right, Paul, thanks so much for joining the podcast today. I'm excited for the conversation. I've known you for a while, and I'm excited to kind of share this conversation with the rest of the audience. And so we always begin these episodes to kind of put some context with all the guests and where they came from and kind of how they got on the track towards additive. So let's start at the very beginning. Kind of where are you from? Kind of what kind of was your first kind of baby steps into kind of where you are today with additive manufacturing?
Okay, where am I from? You mean location-wise, or?
Yeah, early on. Like where'd you grow up? Where were you born?
I was born in Massachusetts and moved around a bit. My dad was in the shoe business, and we traveled from wherever there were factories open to keep working. And I lived in Maine for a while and out in Ohio for a brief period of time, and then ultimately ended back up in Massachusetts when I started working.
Awesome. And so, what was did you stay in the shoe business? Was that kind of the first?
Oh, my dad said to stay out of it. Said, don't go into the shoe business. So, of course, I made every effort not to. I got a chance to work for a medical company for a short period of time, helping with the engineering department and their intra-aortic balloons, if you're familiar with those. It's a device to assist a heart that's failing to keep the patients alive. But then moved into working in an industrial design company for a short period of time when I realized I needed to find something more interesting, and started for a company that supplied orthotics, or those footbeds in shoes. Once I started doing that and got into the tooling, it opened up the career of getting into the footwear business.
And so when you were growing up, did you get to see see inside some of these factories that your dad was working on? Was that
It was a common experience to go, visit dad, because he worked, in those days you worked Saturdays, you worked whenever you had to get work done. So we would go in together, and I would hang out in the factory and go assist the box maker one day because I was bored, and he wasn't afraid to give me a very sharp knife at a young age, and just played around the factory and got exposed to the different steps it took to make shoes, and got to hang out in the leather storage bins for a while, because that's always a unique experience. And then, that really pointed out how things are made and how factories work, and how all those steps that are needed to put things together, and how each one influenced the other was really kind of neat to learn at a young age.
I'm sure, and kind of gives you some context of kind of what potential jobs are out there, at least when you're working with your hands and doing.
Yes.
Right.
I learned right away that the cement application people was not the job for me. It was dirty and the chemicals were nasty, and I knew right away that's not where I want to be.
Yeah. And so what kind of after the medical device area, kind of where was the first introduction to 3D printing? Where did that come in?
Well, I was late to the game. When I graduated college was when the first patents came out for additive manufacturing, 3D printing, and I'd never even heard about it. I wasn't exposed to it. We didn't have an easy way of looking things up in those days. It wasn't in the Thomas Register. It wasn't in the encyclopedias. So we didn't become aware of it. A lot of folks at that time, and industries that were investing in it were aerospace companies and people that really didn't share a lot of what they were doing with the technology that early along. So it wasn't until I started at Reebok and worked there for several years before I first was exposed to it. I'd already been a machinist and built tooling for molds and parts for shoes for many years. And then I finally heard about 3D printing and thought, that's really something interesting. I need to learn more about it.
So what was interesting about it when it comes to kind of the footwear design?
Well, the parts that I was mostly focused on were midsoles and outsoles. And in athletic footwear, they were becoming more and more organic every day. They were not flat, square blocks. They were things that you couldn't just hold in a fixture or in a vise. So as with some machining experience I already had, I knew that machining those would be very challenging. Multiple tool setups. If with a 3-axis mill, you'd probably have to set the part 4 or 5 times to be able to machine all of the sides of it. You'd have to have very custom and specific jigs to hold it in place. So when I saw what 3D printing provided and how it could eliminate some of the needs for that with fixturing and jigging, because it basically could create quite a bit of different geometry without really having any structure supports to it. That was something I wanted to look into further.
And so was there kind of a 3D printing group that was started in Reebok? What was the kind of evolution of that?
Me.
Okay.
It was just me. I'm reading magazines and trying to find articles and trying to locate the information because we didn't have internet to search for it. At least we didn't have it at Reebok. So, and just for context, this is just before it was right before 1998, so right around 1997 was where the big search started. And I had to find it out by reading magazine articles and making phone calls. So I did my research and found that there was a process that could make sense for Reebok. And it was a matter of, okay, now I have a great idea. How do I talk somebody else into it? And that's when I met with management and got a quick introduction to the boardroom and the president of Reebok. And he was very happy to sit down with me, which still surprises me to this day. And I said, hey, we should invest in this, and showed a couple of sample parts I was able to acquire and told a pretty good story, I guess, because not too long after that, he authorized the money to pay for our first lab, to build it out, to build the space for it, to acquire the equipment, acquire the materials, and get us started.
So what technologies were you starting with in some of those first days?
I looked at SLS or powder bed fusion polymers first. The reason why was I liked the idea of nylon as a material being white, which is, as odd as that sounds, was pretty important to us at the time. But it also was pretty solid, pretty rigid. It could take some abuse, and it also didn't require supports. For those that are familiar with powder bed fusion polymers, the powder around the part acts as the support. So when you put a layer down and you do your fusion of the powder that isn't fused just sits there and holds it in place for the next layer. So without having supports, it made design of the parts very easy because we weren't designing for the process, we were designing for the part.
So what went into your kind of business case early on to buy the machine? Like, was at that time, were there many service bureaus? Like today, like I'm guessing for many companies, the cost equation to buy versus outsource kind of parts, it's getting closer, right? Because there's so many different options of printers and service bureaus that you can get parts from. But what did you have to do to kind of convince management to go down this path?
Well, number one, management wasn't well educated in this particular prospect. So it wasn't that I had to fight too hard to convince them that we needed to own it. The business case was pretty simple for us. We looked at service bureaus, but now our IP or information was going to be outside of our space. And in fashion footwear and sports footwear, IP is pretty important. Secondarily, we talked a lot about speed. To get a sample physical model of a part before we had this, it took up to 30 days to get a sample part to see if the design looked right, to make your decision. And a lot of times, if it took 30 days to get that, you need to make a decision whether you like it or not. So you get the part and go, oof, it's not what I want, but it'll be fine. And our thought was, if we could do the prototypes much more quickly, when they see the first round, they could say, oof, that's not exactly what I want. Let's make one change or two changes. We can still get it done quickly, and it's time to market. In a fashion kind of business, your time to market is crucial. If it takes you 18 months to put a shoe out and you can do it in 12, that's a pretty big win. So that was our business model. Cost-wise, it wasn't the top of the list for us to worry about. It was really that time and that being able to maintain IP.
Yeah. And so I imagine even if you were in that same position today with all the new machines and things out there, you'd probably make the same decision, because the IP and speed makes so much sense, more sense internally.
Right. The argument would probably be very much the same. The decision of which technology may shift a little bit, but ultimately, keeping the IP and then getting faster to market would always be the right sell pitch, I think, for prototypes in footwear. Now we know things have changed a bit, and some footwear companies are doing actual final parts that they're being put into shoes. That business model changes a little bit.
And so did the business case grow, or the capabilities grow over time? So you started with SLS and nylon. Kind of where did the technology go over the time that you were there?
Well, we had two big improvements while I was there that really changed things a lot for us. One was that, currently in the SLS process at that time, you could do a flexible as well as a rigid material, the nylon, but also a more flexible material. The flexible material was very difficult to run, but it did work, and we're able to utilize it on occasion. But the biggest breakthrough, I think, was circling back to time. There was a company that started working on a system that used binder jetting to produce parts out of, it was actually a spinoff of MIT, and they called it Z Corp. And you could produce a part that would take 7 hours in SLS, which is still better than 30 days, but now you got it down to 2 hours or an hour and a half. That's a huge jump. And it gave us the opportunity to invest in that process pretty quickly when it first came out, and it was a great success for us. The second big change was when Z Corp again started providing color. Color was a real breakthrough. I used to describe it as saying that, well, when color came into the equation, it added another dimension for us. Because the minute that an engineer could see it in color, the marketing folks, the program manager, all the folks that were involved in it, they were able to see it much more clearly. When it's a single color, white part or black part or whatever, there's a loss in understanding where things fit together and how they look as a final part. But we could now do it in color and actually apply texture, graphically onto the part and make it look much more realistic. And that was a big success for us. Of course, with that, you have to recognize that Z Corp wasn't making the final material for a bottom unit. They were making it out of plaster. So when you make something that looks extremely realistic, we were spending a bit of time replacing the broken ones, because they would constantly try to flex them and see how it felt when you bent it. It's like, you do know this is plaster, right?
I imagine tricks the eye to, and so as kind of, you've had all these experiences where you're working with your hands, different machines, kind of both machining and now into the 3D printing realm. Kind of how did that help kind of operating the systems to communicate kind of how the technology works and what kind of the benefits and limitations are with kind of the designers, the engineers, management that you were working with?
We had some communication with them. They knew right away when they saw the parts that they had limitations and what they could use them for. They always complained that the plaster parts are heavy. It's like, well, yeah, they are. And when we introduced color, we couldn't say, we'll make it in any color you want, because the Z-Core process to get an exact color match sometimes took a few experiments, a few attempts to get the exact color match. And rather than go through that, we provided them a palette of colors and saying, you can have any color you want as long as it's on this little plaque. And that plaque was simply a quick print of the base colors that the software put out with no tweaking, so that we knew we'd get the same color every time. And this is your limit to colors. But if they were willing to wait, we could do custom colors. And in the entire time I was there, if I had more than 4 requests ultimately we had to make probably 4 models that we had to match a color the rest of the time. And I'm talking thousands and thousands of parts. We didn't have to match colors. They were happy with the colors we provided.
And so you've spent a number of years at Reebok. I don't know what was the exact number of years, and you want to talk about kind of that transition to the next thing after that?
Sure. I was with Reebok for 21 years.
Okay.
It was a great opportunity, not just to do additive manufacturing and supporting that and supporting the CAD team, but also I did a lot of footwear development. There's a lot of shoes out there that I had my hand in helping to develop. Some you may recognize, and a good portion of them you probably will never see because they were done for the South American market. But time came to realize that to continue my career, I really need to make a choice and focus on something specific. And footwear was great, and I kept hearing my dad's voice saying, "Why are you in footwear?" But I really loved everything about additive manufacturing. I was able to get involved in it early, but I was also it opened the door for a number of relationships through organizations that really made it such a wonderful experience. I didn't want it to end. So I decided to transition out of footwear and to focus solely on additive manufacturing and supporting the industry and trying to make it a better place for everybody.
And was that about the time you got involved with AMUG? Is it around that time, or was that before?
No, before. I got involved with AMUG pretty early along. It was only a year or two into using the technology when we were having the trouble everybody has when they first start using it. It doesn't work the way the sales guy told you. And we needed to get better at it. And there wasn't a lot of training opportunities. There wasn't a lot of support that was easily available. So we had to start looking for it. And a suggestion from a good friend of, you should check out the user group that's out there. And we started making some inquiries into the user group, found out there was one for, at that time, specifically SLS. And we joined that, like I said, just a couple of years in, and became involved very, very quickly, and found just roomfuls of people that were having the same kind of things we were having, some solutions we needed to find. They were there and they were willing to share it, and it made things even much more fun. And then when that user group ultimately combined to form AMUG, just the opportunity to continue working with that organization, getting more and more involved, was a great way not only to still leverage what they provided, but then also to be able to give back to it. Because to get things from AMUG is great. It's a huge help for your work. But at some point, you've got to realize that it's time to give back. And that's with time and volunteer work to go back. And that's when I get much more involved.
Even, probably skip ahead in terms of years, so not exactly timeline, but you spent 2 terms as president of AMUG?
Yep, I was president for 2 terms, and now I'm still sitting in the position of past president.
And so, what's that like? Is that kind of I think we've had Mark on, so we've had multiple presidents of AMUG on the show. So we know a little bit, but kind of maybe a couple words on kind of your experience over that time in terms of sitting in the president's chair. What was some of the challenges? What were some of the unexpected kind of benefits of seeing AMUG from kind of both that kind of microscopic view as well as probably 30,000 foot view?
Well, I think you're going to get maybe a different answer from everybody that's been president of AMUG. At least I would think you would. I know Mark's answer probably be very different than mine, but what I discovered is that as much as I thought I knew about the different parts of AMUG because I was involved for many years. Once you get to be president, when you find out really how it truly works from top to bottom, who's doing the work, what type of caliber of people that you're going to be exposed to from the level of the rest of the volunteers that are on the board and just volunteer during the event. And they're all tremendously talented people that are very, very focused on supporting the industry. Some of the other stuff I found was that you can't make everybody happy, and they will make sure you know it. Let me see, what else would be really good? The other part I think was that you're never alone. As president, I would come across situations that I either wasn't sure how to approach it, or I was felt uncomfortable, or even a little overwhelmed by it. And the rest of the board and just users out there, I reached out to, just saying, hey, give me some advice. They were always there for me, and that was really helpful too.
And you were, that was probably what is it, 3-4 years ago that you were kind of in that role now, or maybe I'm losing track, but that was also a pretty big inflection point for the industry, right? Like a lot of more companies kind of coming in, and the conference grew as well during that time.
Yeah, during my time, we really saw the biggest growth. And believe me, it has nothing to do with the fact that I was president. But we saw a significant amount of growth because the industry was really starting to become well known. There was a lot more exposure to it. A lot more people were getting into it. Younger engineers that were getting through school now had been exposed to it and were trying to adopt it more often. So I think that was what led to a lot of the growth of it. And as a user group, obviously you need to be a user to attend, and the solid growth in the user base, more and more people doing it, led to that growth. Due to COVID, of course, things have changed, but I fully expect once travel and people open up and businesses are back to normal, we're going to see that growth start up again and continue to grow even more so.
For sure, and exciting to have it back in Chicago. I'm spoiled by the fact that it's been here like 5 last 6 times, or something like that. Not that much, but
not that much. No,
like,
but
my travel expenses have been nice and low because of that.
Yeah.
So, speaking of Chicago, from Reebok you moved kind of out to the Midwest, and we're at UL. That's where we cross paths a number of times. So kind of talk a little bit about that transition and what you were doing there.
Well, when I left Reebok, to find the right opportunity that made sense for me, that allowed me to really look at supporting the industry as a whole and helping users get better, helping OEMs get better, helping everybody get better was a goal I had put for myself. And when the opportunity at UL presented itself, it made a lot of sense for me. I got a chance to get into training and providing training and being an instructor. And that was a huge shift in my career, but I couldn't ask for anything better because it was just really a lot of fun. And every single student I've taught, and there may be 1 or 2 that actually watches this, they were awesome. And I appreciate every one of them because they made me better every time I taught a course. But on top of that, with facility safety and some of the other UL programs that were put together, we really were able to start to look at how the industry can grow and move toward a production environment from a prototyping environment. And I got a chance to really get involved in that early and support that. And that was an awful lot of fun too.
And that's a pretty interesting perspective too, to have like that kind of goal to kind of further the industry. And so it's kind of going from the user side to maybe kind of in this intermediary kind of integrator kind of side with UL, where you're talking to end users, you're talking to equipment manufacturing, material suppliers, like all of them need to be in these conversations, even standards organizations, right? Like it's the industry doesn't necessarily go forward with any one of those missing. And so kind of being in that middle part is kind of gives certainly a very unique perspective.
It actually does. And it's interesting how it opens up even more opportunity to interact with people. Because as a user, you've only got a certain amount of interaction with other users that are outside your business or outside what you do. And also you're a customer to the OEM, so your exposure to them is still pretty limited. Once I got to UL and I started interacting with OEMs more, really becoming more of a support to them versus a target audience as a customer, made a big difference in those relationships. And certainly with being able to go from a medical company to an aerospace company to all these different places that a sneaker guy typically doesn't get to go to, was really eye-opening for me, and also a chance again to look at how we can support those industries in moving forward with the technology.
And I imagine too, at the same time, like the experience you've had in operating the equipment and bringing in the equipment, using equipment, like the same challenges, whether you're making shoes or making parts that go on a B-2 bomber, like there are certainly similarities across that whole materials and process and standards side of things, that kind of the context, the background may be different, but like the underlying challenges remain the same.
I agree 100%. You're still talking about the same layer thicknesses and laser powers and extrusion speeds and nozzle diameters. It all is the same conversation.
And so, I mean, kind of sticking with that theme, kind of spent a number of years at UL, kind of also in kind of the standard space. Today, you're talking to me from kind of the position at ASTM. So, kind of what do you do now in terms of kind of maybe like even take a step back of kind of, for those who may not be familiar, kind of what is ASTM, and then kind of how did you end up there, and what are you doing?
Well, I've been with ASTM for just short of 2 years now. And what I found is how little I knew about ASTM before I joined. It's a very interesting organization. They've been around for over 100 years in the development of standards for just about every industry you touch on, whether it's medical, it's oil and gas, it's concrete, everything it's pretty unlimited number of areas they touch on. And what I found is that, they don't write standards, they facilitate the creation of standards. The standards that are created by ASTM are created by industry experts that have joined and got involved in the standard creation, and people that really want to be included in that process of developing the standards. And it's a process they call consensus standards, meaning that these individuals all get together and start drafting the standard, and then they have to complete it and vote on it through a balloting process to make sure it's something that they all agree to, and that's a consensus standard. Now, it doesn't happen overnight. It actually can take quite a bit of time to do this type of creation of a standard, but ASTM created a center of excellence for additive manufacturing to look at how they could, again, support the industry by getting the standards created a little bit quicker through a concept of research to standard, or providing the support for the research side so that we can, through our partners, get the research done to help get these standards facilitated quicker, to again support going to a production environment for the using the technology.
So the idea is like there's certainly industry needs that kind of need standardization, but in order to make that standard, you have to generate some data and have some facilities or resources to do that. So ASTM helps in that sense, or the partners in the Center of Excellence help with facilitating that, so that the subject matter experts or whoever's making the standards can say, hey, we need data on this material set or this machine, and that'll help with the standard. Is that kind of the idea?
Yeah. It's the idea is to really whatever can be done to accelerate it. As an ASTM employee, we can't influence the standard, can't create it, but we can certainly support the process in any way possible to get it there quicker, because that ultimately helps the end user, whether it is in additive or not. Because when you're doing any kind of manufacturing, you have to manufacture to something, to a measurement, to a standard. And without those standards, it makes things much more difficult.
And how does ASTM find is the focus member driven? I mean, there's at least 7 kind of families of technologies, but then within that, there's dozens of types and iterations on different types of equipment and different materials. So it seems an ever-growing pool of things to try and standardize, or try to at least pick kind of what's most popular, what needs the most demand in terms of standardization. So how does that process of like focus or prioritization take place?
From what I understand, it is member driven, and that's why in some cases there may be a bit more of a focus on one area or one technology or one material type over another, simply because that's what the members or the industry is putting the most oil on that squeaky wheel.
Mm-hmm.
But ultimately, as when people ask me why is this standard not available, the answer is, well, maybe you should get involved with ASTM and help support that happening in the future, because as a user or as a member of ASTM, you can certainly help facilitate getting that standard, or help push to get that standard created, for sure.
And so what specifically are you working on in terms of ASTM?
My goal, or my target right now with ASTM, is to continue with that education and workforce development. We know that as much as I was desperate for training when I was early into using additive manufacturing, there's still a need for training now. And with it moving toward a production environment, the training is even more important to be more standardized, or more to standards. In the early days of training, you learned how to break a part out using a brush to remove the loose powder, but it was a prototype and nobody cared. In production, can you use a brush? What kind of brush? What can it be made from? What can't it be made from? And that's where those little bits of information, where you can reach to a standard or reach to a best practices, really helps a lot. And that type of training is really important, and that's what we get to work on. The great thing about the ASTM training is that we are leveraging a lot of industry experts to be the trainers, to be the ones that deliver the content and help create the content. And we have a education workforce development advisory board that actually reviews the content and vets it out, so that we really are delivering the best content. And my job is to help facilitate all those moving parts to get the training actually put together and delivered.
So is this something that is credentialed by ASTM? Like you can get a ASTM certification for X and Y?
You can get a certificate
Okay.
we have a general additive manufacturing certificate course that we provide a few times a year. One's actually coming up very soon, and you get a certificate for that. Also, we've got some more advanced trainings where they're role based, and you get a certificate for taking those, and you can become like for quality assurance, you get a quality assurance certificate for taking the quality assurance course, or if it's a safety course, you can get a certificate for that. And some of the other courses like cybersecurity are becoming available as well.
So who's the typical audience for these? Is it someone who's already experienced with, like, is in a company with 3D printing, someone that's like upskilling, or kind of where are you guys targeting? Or where do you see, maybe a better question is, kind of where do you see the growth in terms of finding that kind of additive workforce of the future?
Well, I think as roles are better defined, that's going to help put together kind of a target audience for some of our trainings. Right now, our trainings are really, openly available to anybody. But what we find is that some folks are better suited to kind of get a taste or an introduction to it. So we have webinars we put on every month to kind of give that introduction to some of the terms and topics. And then once they've taken a few of those, they may want to move into the general certificate course. But if you're really well experienced, the certificate course is good for you because it covers the entire process from start to finish, with design, with feedstock, with testing, non-destructive testing. All those are in it, so that you get a real wider swath of additive manufacturing over that education period. You're not just getting one little course. You're getting all the different segments, which I think everybody could could utilize that information.
And is this a combination of both online and in person, or like different courses have different components? Or
the webinars are obviously
online. Right? Yeah. Sorry.
But the general certificate course initially was delivered face to face, and then due to COVID, we moved it all to online. But now we're transitioning back to face to face again, because training that's delivered face to face has much better effective rate than one that's delivered online. And it's not due to instructors or even to the students. It's that interactive piece that you get. In all the years I did training, there was so much interaction, and the course really would kind of adapt to the room sometimes, where you get a lot of questions and leading in one direction. The course would kind of veer off course tiny bit to accomplish that piece. Of course, obviously circling back to the main topic, but it gave you that flexibility when you read the room and you get a lot of questions as you're presenting, as you're teaching. And then within the hands-on face-to-face type of course, there's always opportunities to stop and to review certain items or address a certain particular issue that somebody might be having.
And it's one of those things too, where the people who are likely to take this course, I imagine, like working with their hands, like holding, touching, seeing stuff in real person, in real life. And that probably is a little bit easier to, even if you can show a part, maybe you're not taking it out of a powder bed or something, like you can show a part and talk about overhangs or things like that in person. That just a little bit easier for someone to capture than in a webinar. We typically have whiteboards and various things where it's stop. Hey, wait a minute, that part you had on the screen, bring it back up. All right, now show me how you did the supports, or tell me about why the orientation was this particular way, or how the layering affected the end result of this part. And just being able to answer those questions and show them graphically with a whiteboard, or just waving your arms around oftentimes makes a big difference in the training. For sure. And it's one of those things too, where like we did a kind of a small kind of pilot training course this summer in the west side of Chicago. And the thing I took away from it was all the things that you mentioned, but I think the familiarity, like we take for granted, like knowing names like Renishaw and EOS. And I mean, you ask the average person, like that's not Amazon, that's not Boeing or Target or something, or Starbucks, right? And so just the nomenclature of like, hey, like there's this whole almost not a subculture, but like culture around additive manufacturing that has all these different names is eye-opening to people. And like you say, hey, that's a couple billion dollar industry or a few $1 billion industry, that there's all these opportunities there. That was something I kind of took for granted, just being kind of immersed in a daily basis.
No, I agree. It's, as I get more experienced in additive, when I meet someone, it's their first day or first week and they've never seen it or heard it before. It really makes me think for a minute, wait a minute, I was that guy. At one point I knew nothing, and it's great to be given that refresher of what it's like to need to learn the basics and to understand the terminology and the different topics that or questions that can come up during that process.
For sure. And so kind of as we kind of wind down kind of the interview, like what are some of the things that are on your radar for 2022? What's exciting? What are you looking forward to? Any kind of cool events that ASTM or projects that you're working on that you can kind of speak to or want to share with the community?
Sure. Well, number one, I still have fun every day, and I look forward to it simply because of that. But some of the upcoming stuff that I'm looking forward to this year certainly will be a mug, because I'm still a part of that, and I thoroughly enjoy that event in Chicago this year. But some of the other big events I look forward to as well. And in the fall, ASTM is going to be putting on their ICAM event, or International Conference for Additive Manufacturing, and it's a very different event. I say that because I've been to only one so far, my first, and I was exposed to a different level of understanding for additive manufacturing. With the majority of the speakers, and there's tons of speakers. I think there's like over 500 or 600 speaking opportunities through the week. And they touch on very, very targeted areas, whether it might be aerospace or it might be in cybersecurity or construction or polymers. But there's I think 24 or 25 different categories or symposiums, as we call them. And they're deep dive ones. They're researchers. There's the people that are inventing something new that presented this course. It's very high level and scientific. And it's, I'm no scientist, but it gives me an opportunity to kind of geek out all over again when it comes to additive. So in some ways, like it's my first time seeing it. It's a really great event. And I think that's probably the one I'm looking forward to most. Again, it'll be face-to-face in Orlando this year. And it's it actually starts, I think, on Halloween, which is fun. I'm trying to talk everybody into wearing costumes. So far, that's not working out, but I'm going to keep trying.
Hey, you can always wear a costume, right?
Aren't I always wearing one?
That's right. Awesome. So I guess the last question I like to ask this of everybody that comes on, kind of put yourself back in the shoes of being the person that may not know much about additive or trying to maybe further their career with some different training or upskilling. Like, what kind of advice do you give someone that's early on in their career path when it comes to 3D printing and additive manufacturing?
Well, I think going back to my earlier comments about how hard it was to find training. For those that are starting out, pursue training, find it. Don't rely on the OEM, though their trainings are all good. They're usually very narrow banded. They teach you about their equipment and their device, but there's so much more to additive, whether it's design for additive, whether it's managing feedstock, whether it's non-destructive testing, part finishing, post-processing. There's all sorts of areas that really kind of need to live on their own when it comes to training. Pursue those trainings and pursue ways to learn more about it. I assure you, no matter if you've been in the industry for a year or, in my case, close to 24 years, you're never going to stop learning about it. I look forward to ICAM because that's my one way of learning all kinds of stuff I've never even thought of before. But learn and continue to seek out training and don't forget the most important thing is, in my opinion, additive manufacturing is a very fun industry to be in. It is one of the most close-knit ones I've ever belonged to. And I would recommend to anybody who has the interest in it to stick with it and get involved and look beyond what you're making today and look to what can be made and what the future holds for the industry itself.
Awesome. Well, always good to catch up, Paul. Thanks so much for joining the show today.
Oh, thanks, Mike. Anytime.